So hi everyone, thank you for joining today for the first iteration of the NablaFlow webinar. I'm Thomas. I'm in charge of the development of ArchiWInd, one of the software that we develop here at NablaFlow. Today we want to share with you something about CFD. We will speak about urban planning and the wind effect that happens in cities and how to mitigate those effects during your planning design. So it's mainly dedicated to architects, but many of the takeaways that you will get from this presentation are general and can be applied to many fields. So without waiting, let me tell you what we'll speak about today. So firstly, I want to emphasize why would you care about the wind while designing a building. So I'll show you why the wind can be dangerous and what are the levers that you can pull to mitigate it at early phase. Then we will speak about the philosophy of building higher in cities and why it's making the wind-related issues a topic that is more and more concerning. Then, in a broader picture, we'll speak about the regulation and how the cities are now putting a legal frame on how to develop cities and how to build new buildings. In the second part, we will go through the Urban Aerodynamic 101. In this part, I want to focus on giving you the main physical effect that you can encounter in cities and that you need to have in mind while designing a building. And we will go through that through our platform, ArchiWInd, and then we will go back to an actual case and apply those physical effects to a real project and how to spot the issues and how to mitigate them. So I will go through the presentation without interruption, but if you have any questions, please note them down or write them in the chat. But please make sure to watch the webinar because we got some surprise for you at the end. So in the first part, I would like to focus on why we should care about the wind while designing a building. For this first case, I'm going to bring you to Leeds. It's in the UK. And we're going to speak about what the Guardian called in 2014 the Killer Tower. So for a little bit of context, this building was built at the middle of the city of Leeds. That was the highest building in the area. Soon after the construction of this building, the wind condition at the base starting to be quite worrisome. The municipality knew about it, but until one day where a lorry passed in front of the building and due to this really turbulent and hazardous wind condition, flipped on the side on a pedestrian, killed one pedestrian and injured another one. Why I'm bringing this terrible example now? It's mainly because in a broader view, I want to emphasize that the early phase mitigation will bring you way more power than later retroactive fixes. In this case, an early stage assessment on the wind would have given to the municipality way more leverage in order to mitigate this terrible situation at the base of the building. Now, the strategy that they need to adopt is to create complex ad hoc elements and complex system of baffles and canopy in order to mitigate a phenomenon that could have been mitigated in early stage. So of course, these kind of terrible situations are not so common, but we want to avoid them. And the problem now is that the philosophy is to build higher and higher in cities, and high rise is bringing this kind of issue. So now I'll speak about the problem with the skyscraper and the wind effect that they cause. So we'll stay in the UK. And I will keep using the press as the main source to report the issues. So I will speak about the two skyscrapers that are in the city of London that are nicknamed the walkie-talkie and the cheese shredder. Those two buildings create a fierce downdraft. So downdraft is basically bringing wind from the high atmosphere down to ground level. and this wind has a high velocity. Let's move to Toronto. So with more specific data and not only feelings, there is this broadcaster from the global news that measures gusts between 30 kilometers per hour and 45 kilometers per hour on one corner of a 55-story buildings, the Four Seasons, but on the other side, it detected speeds of just 5 kilometers per hour, slightly north of the building. What is the problem with that? We create high gradients of velocity in cities that can basically surprise pedestrians or cyclists that are going from low velocity zone to high velocity zones, and can destabilize them and conduct to injuries, or at least complaints and unsafe paths for them to go through. So the main danger is that we can feel the wind, but we cannot see it. And when we feel it, basically it's too late. So how could we see it in order to understand it? The answer is given by the CFD, computational fluid dynamic. The CFD allows us to predict the wind before creating the building, which allows us to understand the patterns of the wind around the building before it's actually created and it's too late. So it's used already in the structural engineering to make sure that the structure doesn't collapse because of the wind load and the interaction with the structure and the wind. And I'm going to give you the example of in Dubai of the Burj Khalifa. So they used the CFD to make sure that the interaction with the wind and the structure and the vortices that are created by the wind wouldn't make the structure collapse. But they also use the CFD to make sure that when the tower will be built, the area that are at the base of the building would be able to be used in the intended way, so that they would be comfortable and also safe. So it might be the first time that you hear about wind being that much of an issue, but for cities it's something that they start to tackle. They start to put a legal frame on how to build buildings to mitigate those problems. For example, the City of London in 2019 wrote a set of guidelines for the new building in the City of London. In these guidelines is described which buildings are going to be under the regulation, but also how us wind specialists needs to assess those buildings. So the buildings under the radars are going to be the one that are higher than 25 meters and that are in wind sensitive area, so basically close to River Thames. And so the second part on how to assess those buildings, we are doing it through CFD. The guidelines make sure that we're using the right resolution and precision to grasp all the patterns of the wind, and us at NablaFlow, we are following these guidelines in order to produce wind studies that are relevant for this environment. In order to report on the comfort, we're using wind comfort standards. That's basically a way to quantify the wind comfort that everyone agrees on. The City of London used modified Lawson criteria. I'm not going to spend too much time speaking about wind comfort standards, but if you're interested into having more details about wind comfort regulation and how we are doing things at NablaFlow, please just get in contact with us. So now we will go through the Urban Aerodynamic 101. It's the part where I want to give you some physical takeaways about wind effect and how to spot them in your building projects. So to do that, we will go directly to our tool. We have a web page for each simulation where we can visualize the result in a 3D viewer, and it's going to be the easiest way to show you how to spot the issues, and it's actually really easy. Now I'm on the web page of ArchiWInd. So I made this simulation really quickly. So on the web page we can find the amount of wind direction, 8 wind direction, the diameter of the area, and the coordinate. So on the web page here I downloaded the model on the 3D viewer. Now we can see the pedestrian wind comfort. That's not the field that I want to show you today. I want to go through the wind speed scaling factor. In here, we can specify the direction from which the wind is coming. For the first effect that I want to show you, I want to put it on the southeast direction. I want the wind to hit this building. So the first effect that I want to speak about today is the downwash. So let me increase the size of it so we can see it better. So what's happening now, and I'm going to put the particle for us to visualize it even better. The wind is directly hitting the facade of this building and getting pushed on the side up, but the main concern is that the wind is getting pushed down. How can I see that? First, I see that the particles are getting away from the building, so it means that it's touching the building, hitting the ground, and being deflected down and away from the building. I can also see it if I look at the turbulence. I see that at the base of the building there is a high turbulence. So that's the two main characteristics of the downwash. In order to mitigate that, the simplest way is to either reduce the area that is facing the dominant wind direction, so rotating the building, or creating structure on the facade to deflect the wind that is getting pushed down. The second effect that I want to show you, and I will go back to the wind speed, is the cornering effect. So we can see it at the corners of building. We can see it here mainly. We can see it also here. Basically, the building is accelerating at the corner of the building when it detaches from the wall, and this effect can be mitigated by creating smoother edges for your buildings. The third physical effect that I want to show you is the channeling effect. So let's look at this street. So I'm going to put the wind blowing directly in that street. So now we have the wind, I want the wind blowing from the west. So as we can see here, the building is accelerating in this street. We can see the particle going through it. What's happening here is we narrow the section, the wind is accelerating because it has less space to pass. It's the Venturi effect. There is a buildup of pressure here, so a part of the wind is going to go higher, but it's still going to be an issue because it's going to accelerate in that street. How to mitigate that? Placing a canopy here, trees, would reduce the amount of wind and create turbulence. It's going to lower the velocity of the wind in this channel. We can also see it here in this little tunnel. Here. So yeah, that's basically it. Yeah.
Perfect.
So now in this last part, we're going to see how to spot issues in real projects. So I will go back to the killer tower that we mentioned at the beginning and see how early stage volume study would give us insight on what is happening in this area. So I'm going to go to ArchiWInd again. So I loaded already the 3D viewer. In that one, I put I'm going in the speed, and I'm putting the wind direction to the west. This is the main wind direction that we can see on the wind rows. So what we can see here is that the wind coming from the west is hitting directly the facade of the building. So as we saw before, we can spot the downwash effect here with the particles that are going away from the facade of the building. And we can see also a strong cornering effect. So those two wind effects are really easy to spot using the 3D viewer. And so the mitigation strategy that they put now are located around here with deflectors and also baffles and canopies on the facade. With this early stage study, it would result, the main conclusion would be to tilt the tower would be the most effective way to limit the amount of wind that would be channeled down and on the side, basically exposing less of the surface of the tower to the main dominant wind direction, which is really strong. So with this example, the main takeaway is that now it's simple and affordable to carry a wind study. The wind effects are simple to spot, and the value is high when the area ends up being problematic. Doing a wind study at early stage gives you the leverage and the intel that you need in order to create safe and comfortable space without having to guess. Today, what did we learn? Now the regulations are putting a frame and spotlight on wind-related issues. Secondly, early studies are important because you have the freedom to move around the volumes and is the best leverage regarding wind issues. Thanks to CFD now, wind studies are actually cheaper and simple to set up. If you want to give it a try, just get in contact with us with the information on the screen, and we will be happy to help you set up your first wind simulation. Now, this webinar is over and we will go through the Q&A.